Hi everyone, and welcome to today's coffee break session about time series analytics. And today, what you will learn and why it should or could matter to you is you will see a lot of things and learn about a lot of things, what you can do with time series data in Altair RapidMiner. Especially today's focus is AI Studio. So, like the title is already stating, it's as well about windowing. But before we're going into the concepts about that into more detail, one reminder to when it comes to AI Studio, there's a lot of content regarding time series. There's a full-on extension which is just there for you to support you with handling and wrangling your time series data, and as well apply different methods on top of your time series data, like ARIMA, like Holt-Winters, like different algorithms, for instance, to support you forecasting your data. On the other hand, as well, there are operators which support you on decomposite your time series into the trends, the seasonalities, and as well, it's about different types of aggregation, feature extraction, fast Fourier transformations, so on. But later, more to that. Most importantly, to use this, all you need is time series data. And therefore, all you need is basically have this kind of data in your data set. It's quite common if you look into manufacturing or supply chain, time series data is everywhere. Telemetry data, supply chain data, orders of the last months, last years, where you want to forecast, oh, what will be the stock of my inventory next week, next month? Or for instance, you want to know, is everything right with my turbine? Am I in a normal state, abnormal state, or want to detect anomalies of my running machine, my running asset? And a lot of different use cases where time series data is needed. And to really work with time series, just before going to in the software and show it how it would look to you, just the base concept of it is windowing. And for a lot of use cases, you will need window or windowing functions for it. And windowing is something which is super simple, and I will mention it shortly in the software multiple times. So just want to make sure you understand what the concept of windowing is before going into the software. So to creating in your data set, you want to predict something. For instance, you want to predict what's the temperature next week, like in this example, when we had temperature data set. Therefore, we will extract the data from a certain window, like in this case, from row number 1 to 5. And we want to extract over this range, maybe the average humidity, the highest point of humidity, the lowest point of humidity. Same of the pressure would take the average, the highest, the lowest. Same for the wind, and same for the temperature. So we want to extract features, but we don't just want to have this for this first window from the 1st of October from 1 p.m. to 5 p.m. We extract this for this window, and then the next window will be from the 2 p.m. to 6 p.m. We take another window, extract the important information, and then we move on to the next window. And we do this through the full time series, basically. We run a window step by step by step by step by step through the data set. And by that, we can extract the right information. And this helps us a lot and yet to have precise forecasts and make the right assumptions onto your data, and in the end, do the right predictions and apply the right machine learning models on top of it. And how this looks like in AI Studio, which you most likely already saw in one of the previous coffee breaks, is like that. First of all, when we navigate to our operators, there you will find the time series folder under modeling. And there you will find all the important operators related to time series analytics. And for our use case today, we have some telemetry data. So basically, we're having our timestamp. Can as well quickly put our timestamp on top of it. It looks better. And on top of it, we're having then, based on our timestamp, different sensor measurements for different attributes. And what we want to do with that now is we want to extract the right features to in the end build a regression, a prediction machine learning model. But before that, we quickly want to check if is our data complete, because what is really bad on time series data is missing values need to be treated directly. And we see again, we're having some kind of issues with missing data. When we check our data set, most likely the type will stay the same until the type would change. So therefore, we will replace it, the series element, by the previous value. Could be the next value, interpolating, applying certain values. This really depends on the use case you want to follow. And now what we want to do is now we want to extract the important information so we can use this data set now to predict, for instance, if my turbine runs in a normal state or an imbalanced state. And therefore, we configure here, first of all, our process window, which describes, okay, we want to extract always the features of a window of 1000 samples, and we apply this every 100 row items, we apply another window, basically moving with that through the data set. So just before that, we check how big our data set is. Therefore, we quickly run our process up until then. And we're having a data set around 10,000 samples. That means we will have, like, if I'm not mistaken, 90 samples. And in our process window, we do different things. So now let's really elaborate this for the first 1000. So basically our first window will be the first 1000 samples of that. And therefore in the first step, we want to extract the aggregates. We want to know the mean, the minimum, the maximum, the standard deviation. And that's the first thing what we would do. And you see now, okay, we have for each attribute now the mean, the min, the max, the standard deviation for attribute 1, same for attribute 2, same for attribute 3, and by that we extracted the information. Another thing what we could do is we can as well extract polynomials as well, helps to just increase the amount of features and information power to predict better. Another thing which is always super useful and is basically used especially by engineers on a daily basis, and as well I use it in multiple projects where it's always great, like Fourier transformation, to translate our time series signal into a amplitude based or frequency based visualization in data. Just helps a lot, because with that as well we can now, for instance, get the frequency domains from all our attributes we have included, and same we can as well quickly visualize that, which as well is super nice. So we can as well see, like we have here some harmonies and having some points on the frequencies where it spikes. We know, okay, that's a common frequency, and just quite super useful to extract features. And now we use these peaks and this information of when the peaks of those frequencies are as well in our model. And as we now have extracted all of this, we run this not just now, basically this was now run for the first window. Now it would have been run for the second window, but to make it fast forward, we just simply remove our breakpoint in here, and we now run it through all our thousands of windows. And now we have like 90 samples as quick math, 10,000. We have 1,000 windows with 100 steps. So we create 90 samples. And for each of those windows, we see now, okay, we have a window. And with that, we're having then all of our attributes. And this now we can use now into our machine learning model to have a quite precise prediction on when our turbine will be normal or not normal. But we already had a lot about how we would now treat this data set to create a machine learning model. So that's something what you already can revisit previous coffee break sessions for, because in the end now you would just treat this, for instance, a normal neural network or a normal gradient boosted tree, XGBoost, after some feature selection. But I rather want to touch on something else, which is quite nice and quite often can be used in time series data. So let's just switch the use case from some turbine data where stuff is running now to more like typical shipment data from the supply chain. So we're having in here reports from each month. Let me just move to the right place. We're having here reports from January 1st each month, like what's the monthly shipment have been. We can as well visualize. We see like there's some seasonality in. We already can see that just by our eyes already. But what we want to know first of all is now we want to know, okay, what of this is seasonal effect? What of this is a trend? And if there's anything random into it. And therefore, there's a nice thing called STL decomposition. STL decomposition does exactly that. The algorithm takes a time series signal and then decomposites it into the different signal patterns. So basically into the seasonal portion, to the trend portion, the seasonal portion, and the rest of it. And we can quickly revisit now the result for that. And we see now, okay, we're having again our monthly shipment. Now we're having a trend, the seasonal portion, and a reminder, the rest of it. And if we now visualize this again, in the first step, this is like our original signal, what we would have. And now we can decomposite this basically in. There is a trend portion. There's a seasonal portion. Seasonal needs to be steady. Makes tons of sense because otherwise it wouldn't be seasonal. And then we're having some reminder, which would then be the rest. And those two things together would be again our seasonal signal. And you see here nicely again, like how the trend really fits onto our overarching line of the monthly shipments. And that helps a lot, like those decompositions, to then focus purely on the reminder to understand random effects into the data, and as well understand the trend if like actually our shipments are increasing, decreasing, how's it performing, and we can work with those features again further for forecasting use cases or other use cases. Another nice thing what you can do with that is quickly is like just on the spot, if you just have a series signal and you have like your monthly shipment data, you can do forecasting. Could be as well your sales data, or you just have a time series. You have not much information, just a little bit, but you want to know, okay, what will be the next 3 months, 5 months look like? Therefore, ARIMA is a really nice way to do this, which is like basically autoregressive model using the moving average to predict your data and your, basically in our case, the monthly shipment. And again, we would now have here our date, we have our monthly shipment, and as well now we forecasted it. So basically, now we consist here basically out of our monthly shipments, which we use as to train data. And additionally now we forecast on what will be how the next 5 months of shipment of information would look like. This case is like you always have some kind of seasonality, goes up, down, a little bit up, a little bit down, then again up, down, a little bit up, then goes a little bit down. If we would now span this further and focus it further, it would go up again. And that's basically what you as well would configure into ARIMA. Your forecast, you define how much in the future you would want to look this like. And with that, you're able to have quite a nice way to have precise forecasts for your time series data, which not introducing that much complexity. So the other option, basically, if you have this data set and you have nothing more, you have 2 options. Either you create tons of features based on your date, you can extract features like your month, your day, is it summer, is it winter? You can create a lot of features out of the date by itself as well. And the other option is you use just this information and you use just the shipment information as it is, and then apply ARIMA forecasting on top of it to basically use this to have a rough indicator, a rough predictor on the future. There are different ways of what you can do. Either you go deep into the feature extraction, which is mainly based on the timestamp, or based on the windows, what you saw earlier. And the other option is sticking with less complex models like the ARIMA. And that's again for today. If there are any questions, happy to answer them right now. And otherwise, we will see you next week again. And with that, I wish you a wonderful week. And thanks for your attention.